Hello everyone, welcome to another C++ template metaprogramming video. This video isn't actually about templates yet. That will be in our part 2 video where I talk about std forward and perfect forwarding. This video, part 1, is about std move, and the reason I'm going to talk about std move first is because in order to understand std forward, you will have to understand std move and move semantics. So, but in order to understand std move and move semantics, we first need to understand what rvalue and lvalue references are. So, lvalue references are values of which the address can be taken, and rvalue references are values of which the address cannot be taken. So for instance, if I create a variable called a and I set it equal to 3, then a is an lvalue reference and 3 is an rvalue reference because you cannot take the address of 3. Same counts for std string. Let's say, or let's just say like this. So b, again, is an lvalue reference because we can take the address of b. And std string, like this part right here, is an rvalue reference because we cannot take the address of std string because that would give us a error. Now, for some reason, it's not giving a red squiggly line, but let me just compile it, and well, you see it says address of temporary, so you cannot take the address of a temporary or rvalue reference. The reason why it is called lvalue and rvalue is because lvalues are by definition on the left hand side of the assignment operator. The rvalue references are by definition on the right hand side of the assignment operator. Now, I said that it is by definition, however, that is actually not true, because we can say int c equals a, but a in this scenario is still an lvalue reference because we can take the address of a. So it is not an rvalue reference, despite of it being on the right-hand side of the assignment operator. So that's basically the difference between L and rvalue references. So, next we are going to talk about these 3 functions. So this one you may or may not have seen before. Well, same counts for this, of course, but I'm going to show you what function will be called depending on which argument we pass. So we are going to create an integer called reference, and it's called, or we set it equal to 1. Then we create another int, we call it const. Const int const reference. We also set it equal to 1. And we are going to create another int, and we set it equal to rvalue reference, which also equals to 1. So, despite of it having the name rvalue reference, it is, of course, an lvalue reference because we can take the address of this variable, of course. So this is an rvalue reference, this is an rvalue, this is rvalue, this is lvalue, lvalue. I see I made a typing error. I see it const reference like this. Okay. So we are going to call the reference function first. So let's say func reference. Then we are going to call another func with const reference. And then we call func again. And I'll make the typo again. And then we call func again, and we don't pass our value reference like this. but we pass std move rvalue reference. So what std move does is it converts an lvalue reference to an rvalue reference. So we saw earlier that we cannot take the address of 1, right? So it converts this value into a temporary object. So actually, you could say it calls the function like this, right? So it converts it to a temporary. But that's what we use std move for, so we can pass the variable. So this function calls this function right here, because this syntax is to indicate that we want only temporaries. So when we call function with a temporary, then this function is called. However, if we would comment out this function, then this function would be called, because an rvalue reference or a temporary can bind to a const int. It cannot bind to a reference alone. It needs to be const. That's the basic rule of C++, right? But let me just show you that the output. So here, this function, or it's going to print lvalue reference first, right? Because we are passing a reference to this variable called reference. So it will call this function. This function will call this function because we are passing a reference. Then it will print const lvalue reference because we are passing an lvalue reference. Remember, lvalue reference is a reference of or a value of which the address can be taken. So because this is const, this integer is const, it will call this function because the compiler sees 3 overloads, of course. One is a reference, but a const object cannot bind to a regular integer reference alone, right? And that's why it will choose this function over this function and this function. Also, it will not call this function because an integer ref or this syntax can only bind to temporaries. It cannot bind to a reference. So yeah, it cannot bind to like if we would comment this out, then we would get a lot of compile errors because this function is only can only be used to bind to temporaries, right? So we can pass 1 here, then it will be perfectly fine, but it cannot bind to an actual physical object in memory, right? So we have to use std-move for that. But we're getting ahead of ourselves, so let's just run the program. So as I said earlier, it's going to print lvalue reference. That's this one right here, because we are passing a regular physical address to function, right? Then we are getting as output the const lvalue reference. That's right, because we are passing a const int object and we are passing it by reference, so this function will be called. And then our rvalue reference is printed, and that's because we are converting the rvalue reference variable to an actual rvalue reference. So this is actually sort of replaced by this. And as I said earlier, int ref can bind to temporaries. So this is perfectly valid, right? But we cannot say integer ref ref equals 3 because 3 does not contain physical memory. But we can, however, of course, do this. But we need some sort of way that we are 100% certain that we are dealing with a temporary, right? So this is not a temporary. So if we call this function, then it may be a temporary. Like if I were to remove this, then I may be a temporary, but it may also be an actual physical object passed to the function. So that's why a new kind of syntax is since C++ is added so that we are 100% certain that I is a temporary object. Here, for instance, we know for 100% certain that I is not a temporary object. It's a reference to an object. And yeah, as I said earlier, we can pass temporaries to this function if we would comment this out, right? So in this case, let me just show you std_move. So in this scenario, it will print lvalue reference, that's this function right here. Then we are passing a const int const reference, right? So it will print const lvalue reference because this type and this type matches, right? So it's a reference to a const object, so that's why this function is called. And here we are saying rvalue reference, and then we move it. So we are converting we are converting rvalue reference to a temporary. So that's the same as doing this, right? So let me just run the program, and what it's gonna print is lvalue reference first, then it's gonna print 3 times const lvalue reference because this binds to a const int ref object, and this is the same as this, and this function calls this function. So yeah, let me just show you. Right, so lvalue reference, that's this one right here. Then we are passing an actual const int object, right? And it's a reference, so that's why this function is called. Then we are creating a integer called rvalue reference, and we use std_move to convert it to a sort of temporary or rvalue reference. So yeah, that's basically the same as this, so that's why this function is called, because a const int ref can bind to a temporary object, as I said earlier, like this. This is perfectly valid C++, right? So this is basically what's happening inside this function. Or you could say std_move rvalue reference, right? So yeah, const type reference can bind to temporaries, but also to actual const reference. So I can also say this, const reference. So as I said earlier, we need another sort of syntax to be 100% sure that we are dealing with a temporary. So yeah, that's why the this new syntax is added to C++ 11, and it's called rvalue reference. So you might be wondering, why would I want to use this? Why would I convert a value to a temporary and sort of select another overload for my scenario? Well, I'm gonna get to that in a moment. First, let me explain you this class here. It's a very trivial implementation of a string. It may or may not have memory leaks in it. It may be buggy, but this is just for illustration purposes. So yeah, it's not production code, right? So a string always contains, of course, a pointer to a heap, location, and it also contains a length. So we have the default constructor here, and we have our, well, sort of constructor when a C string is passed. So what we're gonna do is we are gonna calculate the length of the string, then we allocate that amount of characters on the heap, and then we copy the contents of the string passed in this constructor to this string right here. So then length contains a certain value. So this is creating a copy, right? Very important. It's creating a copy of string. So I'm not going to talk about this yet. Let me just first talk about this. This is the copy constructor. So this is called when someone does this, string is hello or something, and then somebody's gonna create another string, and it's called string2, and it's essentially a copy of string. So now we have 2 separate strings, string and string2. So yeah, string2 is a copy of string, therefore if we edit string 2, then string will remain its original value. So if I would say string 2 equals something else, then string still is hello, right? That's maybe a little bit trivial, but it's well, sort of important to remember that. So what the copy constructor does is it sets the length equal to the past length of the right-hand side of the constructor. Then it allocates, or it allocates the same amount of characters as the right-hand side, and then it copies the contents into our own string, right? So that's essentially what's happening right here. So these are independent of each other. So that's what's happening. But as you may know, this right here is a pretty expensive operation. It's regularly pretty slow, and if the string contains 1 million characters, then this will well, take a lot of time. Also, std copy is of course very fast, but the more characters pass, the longer this operation will take. So creating a copy of a heap allocated object is generally pretty slow, right? So that's why we want a faster way. And the reason, or the solution actually, is the rvalue references. So for instance, we have a string s1, and it's a very large string, right? It contains, for example, 1 MB, right? So 1 megabyte of characters. So that's 1 million, I think. 1 million characters, very large, takes a lot of time to copy. We actually want to prevent calling this constructor because, well, this will take a lot of time. So you may be wondering, well, then don't create a copy, but sometimes we can't avoid it. So yeah, that's why the move constructor is also a tool to increase your performance. So when I pass, or when I create another string, s2, and I say s1, then obviously this, then obviously this is going to take a lot of time, right? It's going to create all these characters, and yeah, we don't actually want that. So what if we could sort of say that we want to use this constructor? Well, we can do that using std move. And what's it going to do? The compiler sees, oh, okay, so you are converting s1 to some sort of temporary, right? So then the compiler chooses this move constructor over this copy constructor. And what this constructor is going to do is going to set our length, so s2.length equal to s1.length, right? So creating a copy of an integer is very trivial, very fast, so nothing to worry about. Then s2.str is copying temporary, or s1.str. So we are essentially creating a copy of the pointer instead of allocating an entirely new string, right? So copying a pointer is just as fast, I believe, as a regular integer because, well, pointers are also just numbers, so creating a copy of a pointer is very trivial and very fast. But the rules of std move imply that the past object, excuse me, the past object, so s1 in this scenario, is invalidated because we are transferring ownership of s1 to s2. So transferring ownership basically also means that the temporary cannot be used again, right? So in that case, we have to set its length equal to 0, and we set its internal pointer to null pointer. So after this is done, string s2 dot, sorry, let me just do this, s2 or s1, sorry, s2 dot str is equals to null pointer, and s1 dot length also, well, also it's equals to 0, because that's what we did right here. And I'm going to show you that this is the case with the debugger, right? So I'm just going to create a string s1, and it's very large. Just imagine this is 1 million characters. It's not, obviously, so. And then we want not to create a copy of s1, but we want to transfer the ownership to s2. So we say std_move s1. So now the compiler knows, okay, you're not passing in a const reference or just a regular reference, but you are passing a temporary. Therefore, it will choose this constructor over this constructor because it suits this constructor more rather than this one. So let me just execute the program, and we are going to set a breakpoint so you will see what's happening. So s1 here is created. As you can see, the str contains all the d's and the length equals to 81. Okay, so now we're going to use step into. What's it going to do is it's going to go to the move constructor instead of this constructor, and that's exactly what we wanted. So it's going to set s2.length equal to s1.length. That's 81, as we remembered. So now you can see length is equal to 81. And instead of creating a heap allocated memory, we are going to copy the pointer instead of, well, as I said, making a copy of it and allocating memory on a heap, which is slow. So yeah, we're creating a copy of the pointer, which is really fast. It's very trivial as well. But as I said, well, we need to invalidate temporary because that are the basically the rules of C++ move semantics, and that's what we are going to do right here. We're gonna set temporary.length equal to 0, and we can just go ahead and change the values of temporary because it's not const, right? So in a copy constructor, you cannot alter the values of hr or rhs, but here we can because it's not const, right? So basically it's sort of passing a reference because s1 is actually altered. So if we would print s1.str, that will be equal to null pointer. So it's also some sort of reference, right? Because s1 is altered, as I said. Anyway, so we are going to set length equal to 0 and temporary.str to null pointer. And unfortunately, we cannot see that in this context, so I will just print or just do this at this line real quick. I need to include. So let me just rerun the program. So again, it's gonna call the move constructor, right? So gonna create a copy of length and a copy of string, which is very trivial, very fast, and then it's gonna set the length equal to 0 to invalidate the passed object, and the str is also equal to null pointer. And then we can see that s1 is now altered, right? So it doesn't actually convert it to a temporary, but it's also some sort of reference so that the actual object passed is altered. So if we would print s1.str, then we would get null pointer, and if we would print s1.length, it will also print 0. So yeah, remember, it's also a sort of combination of a temporary / reference, right? So now we can take a look at s2, and we see that the str now contains what s1 used to contain. So the d's and the length. So if we were to print S2, then we would get a lot of these, right? So yeah, that's basically in a nutshell what std move is. And you also need to remember that you can't use, or well, you can use std move for a lot of things, but you also need to remember that copying may sometimes be faster than using move, or sometimes using std move isn't even necessary. Most of the times you want to use std move for heap allocated objects such as std string or std unique pointer, right, or std shared pointer. So these are an std string as well. So these objects are all heap allocated, and these objects are all movable. An integer, therefore, is also movable, but because creating a copy of an integer is so trivial, there is no move constructor for an integer. So basically, if this was an int class, this constructor wouldn't exist, because creating a copy of an integer would be is generally very, very fast, right? So just like this line right here, it's very, very fast. You cannot, or you can of course use std move on an integer or stack allocated object, but that doesn't make sense. As a rule of thumb, just use std move for heap allocated objects, or for if you're not sure, then just take a look if the object in question has a move constructor. If it does not have a move constructor, then it is not movable. Therefore, it doesn't make sense to use use std move on that object, right? So if you're not sure, just look up the documentation of a certain class or something. But yeah, like as I said earlier, heap allocated objects, you generally want to use std move for that, unless you want, of course, to create a copy. But I believe unique pointer, you cannot even create a copy of unique pointer, so you would have to use std move anyway. But for share pointer, that is not the case. So yeah, I hope this video made it a little bit clear what std move is. And I will see you in part 2, where I am going to talk about perfect forwarding and std forward. See you then. Bye bye.